friends, my name is Amita and in this video I am going to discuss about one more topic of in basic electrical and electronics engineering, that is a source transformation. In my previous video I have discussed about various electrical elements and they are called as an active and passive elements. Now in this video I will be mainly focused on the conversion of sources from one type to another. As you all are aware that the sources are of two types. One is a voltage source and another is a current source. And these sources are interchangeable with the help of source transformation technique. So now directly I am sharing the screen where I will brief you the method of an source transformation. So let us discuss about source transformation. As the name indicates, with the help of this, we can transform the source from one type to another. You know, there are two kinds of sources are there. One is a voltage source and another is a current source. Now, this voltage source can be an DC source and it can be an AC source. Similarly, current source can also be an DC source and AC source. Here I am simply going to tell you the conversion of a voltage source to a current source or a current source to a voltage source, and similar process will be applicable for a DC source conversion as well as AC source conversion. So let us start with first conversion, that is, if you are having the voltage source and if you want to convert that into a current source, so that kind of conversion is called as an voltage source to current source transformation. How we can convert a voltage source into a current source? Okay, as you know that a voltage source, if I talk about an ideal voltage source, that has been represented by the symbol like this. There is I am representing a DC practical voltage source. Its symbol will be like this. We will connect a voltage source with a series resistance of Rin. So this is a voltage source which I want to convert into a current source. So what is the step to convert this voltage source into a current source? See, this is terminal A, this is terminal B. One thing you have to keep into your mind, whenever we are converting a one source to the another type of source, ultimately after the conversion, the effect of the source should not be changed on the rest of the circuit. Okay, so if this is a voltage source, there is a voltage source of V with the internal resistance of Rin. If it delivers the current I, then what will be the magnitude of this current I? That is V by Rin. That means it will be converted by a current source of V by Rin. Now, how we will take the direction of current of a current source? As you know that the current always flows from the positive battery to the negative terminal of a battery. So, if the current flowing in this, if the current flows due to this voltage source, the direction of current will be like this. So, that means the direction of a current source will be decided as per the direction of a DC voltage source. Okay, so by seeing the direction of a battery, we will decide the direction of current, and whatever the value of this internal resistance will be there in series with the voltage source, that you have to connect as it is in parallel with the current source. Okay, so that Rin you will as it is connect in parallel with the current source. So this is terminal A and this is terminal B, and this V by Rin will be equal to R. So this is the equivalent current source. Okay, so I think the step is clear. Let me write the steps. What we did, number one, we have calculated the current due to the voltage source. Okay, in this case that was V by Rin. Okay, then the current source will be the value of that current in parallel with the resistance of R in. Suppose one example, let me explain, that will be more clear to you. Let me explain this with example. Suppose I am having 5 ohm resistance and there is a voltage source of 10 volt. Suppose I want to convert this voltage source into a current source. So if I calculate the current in this circuit, that will be 10 by 5. That means 2 ampere. So what will be the equivalent current source? There will be an 2 ampere current source. Magnitude of a current source will be 2 ampere. And the direction of current, of course, will be upward. And we will connect the 5 ohm resistance, that is the internal resistance of a voltage source, as it is in parallel. So this is the equivalent current source. So the given voltage source will be converted by this value of an equivalent current source. This is a voltage source. Please mind it, the voltage source can only be converted into a current source when you are having this kind of combination. Whenever there is a resistance is connected in a series with a voltage source, then only the voltage source can be converted into a current source. Okay. Now let us see the reverse conversion, that is current source to voltage source conversion. Okay. Means suppose a current source is given to you and if you want to convert into a voltage source, you know that always the practical current source is represented like this, where the current source is connected in parallel with the internal resistance of that source. So this is a current source given to you, and if you want to convert that into a voltage source, when this current is flowing through this resistance, what will be the voltage drop across the resistance? That is I into Rin. That means this current source will be replaced by that value of voltage source. Again, this direction of current, upward direction, can only flow when the DC voltage will have a positive at the upper side and negative at a lower side. And what will be the value of this voltage source? That is V is equal to I into Rin. And whatever the internal resistance of a current source is there, that will be as it is connected in series with the voltage source. So this is Rin and this is terminal A and this is terminal B. So this is the current source and its equivalent voltage source after transformation will be this. So this is a equivalent voltage source. Please mind it, the current source can only be converted into a voltage source when you are having such kind of condition in the circuit, when a current source is having the parallel combination of resistance, then only it can be converted into a voltage source. For an example, suppose you are having 5 ampere current source in parallel with a 5 ohm resistance, then how to calculate its equivalent voltage source? We know that V is equal to, what will be the voltage drop across this? 5 into 5. That means 25 volt. So what is the equivalent voltage source? Plus minus 25 volt, and the resistance of 5 ohm will be as it is in series. So this is the equivalent voltage source. Okay. Now see, if the polarity is reversed, like suppose the current source is given like this. This is 5 ampere. Now the direction of current source is downward. Then how you are going to convert that into a voltage source? Suppose this is A, this is V. Again, voltage drop across 5 will be 5 into 5. That is 25. Now see the polarity of the voltage source. 5 ohm resistance will be connected as it is in series. Now see, as the direction of current source is downward, and the direction of current source can be only downward when the lower plate of a voltage source is positive. So Now the polarity of a voltage source will be like this, and this is 25 volt, this is terminal A, and this is terminal B. So my dear friends, please take care of the polarity of a voltage source when you are converting from current source to voltage source. That means if you are converting current source into a voltage source, then the polarity of a voltage source will be decided by the polarity of a current source. Similarly, when you are converting a voltage source into a current source, then please mind it, whenever you are doing such kind of conversion, you have to take care of a direction of a voltage source. So that's it. Now I am stop sharing my screen. My dear friends, whatever information I have shared in this video related to a source transformation, that will be very useful for you. If you want to learn more about the topic of a basic electrical and electronics engineering, then keep watching my video. Thank you. Goodbye.